Dear ladies and gentlemen, colleagues, guests, dear ladies and gentlemen, let me start the session of Dissertation Council to discuss the dissertation of Gankevich Ivan in mathematics and physics sciences in imitation modeling of non-regular wave of program of dynamics of C objects. Let me declare it started. The decree of the rector of St. Petersburg State University. I, Doctor of Physical and Mathematical Sciences, my colleagues Margarita Sotnikova, Professor, Department of Computer Technologies, and Professor of Department my name is Vasenikov Dmitry Alexandrovich, Doctor of Physics and Mathematics, St. Petersburg State University, Dr. Samsis Timas Kloktis, Dr. Konstantinos Spiro, Doctor of Sciences in Shipbuilding, Institute of Shipbuilding and Ship Technology of Athenian of National Technical University Athens, Athens, Greece, and Vladimir Vasilievich Korenkov, Doctor of Technical Science, Professor. According to the Act of St. Petersburg State University, the work of the Dissertation Council is legitimate if no less than 4 people are present that are members of the approved Dissertation Council. We have 5 members here, including the remote connection with Dr. Spiro, and so the agenda is this. The 2 hours is the duration of this session, and the first one is the presentation of the paperwork that was submitted by the defendant, and then a short presentation of 15 minutes by the defendant, then questions to the defender covering the presentation, no more than 2 minutes per question, and then all the reviews are read out. They're uploaded on the website of St. Petersburg State University. Maybe questions from the members of the Dissertation Council, and then the defendant has the right to answer questions and comment on the recommendations and critique not more than 15 minutes. And then we have a question and answer session involving the audience, not more than 5 minutes per speaker. You have to register to speak in the registry, and then there are concluding statements of the defendant that answer the questions that he has heard, and then the scientific advisor will speak about the dissertation and the defendant for 3 minutes, and then there will be a break in the broadcast of 5 minutes, so that the members of the Dissertation Council could discuss their decision, and then after the broadcast is on again, open voting takes place, and the votes are counted, and then decision to grant or not to grant this degree is taken. And so the concluding statement from the defendant of more than 2 minutes. Please switch off your mobile devices while we're working. Thank you very much. So I would like to say that a live broadcast is on the website of St. Petersburg State University, and simultaneous interpretation is also provided. And so I would like to proceed now to item 1 of the agenda. So my short presentation, the dissertation of Ivan Gankevich in physics and mathematical sciences has been presented. And the imitation regulation of non-mathematical modeling, numerical methods, and program complexes, and it was submitted and duly approved. We have 19 review by the dissertation supervisor. Dated April 19th. April is also on the paperwork. Then also a personal statement of Ivan Borisovich, and the list of addressed to the rector. Then the list of publications of 16 titles. 3 of them in the journals approved by the Ministry of Education of Russian Federation. Then the certificate of study in the postgraduate course that is successfully completed by the defendant, exams taken and passed, including history and philosophy, good, and then and the specialism and English, excellent. The dissertation is also provided in hard copy and soft copy, both in Russian and English. So all the documents comply fully with the requirements of the dissertation procedures at St. Petersburg State University. And now I would like to give the floor to the defendant, and I remind you that 15 minutes. The key issues for the defendant.
Mr. Gankevich, you now have the floor. Good afternoon, dear members of the board. Good afternoon, dear colleagues, dear guests. My name is Ivan Gankevich, and my dissertation focuses on simulation modeling of irregular waves. My supervisor is Dr. Dektorov, specialist of the Department of Mathematical Modeling and Control Processes. The goal of my work was to develop a 3D model to identify alternative models to study wave surfaces. Our dissertation provides a method of calculating the pressure field under the wave surface. We use the 3-dimensional ARMA model, Autoregressive moving average model. The model is normally used in statistics to analyze and project 1D time sequences. Its 4D analogy is used to replicate elevations of wavy surfaces at any discrete point in time. The 1D model was studied by Roshkova, Trapeznikova, and Goganetsa, as well as works by Spamas, Zeldin, and Bukhanovsky. The 3D model can be seen on the slide. The key parameters of the model are coefficients of autoregressive coefficient and the MA coefficient with normal distribution. The coefficients, the model parameters, are determined based on the auto covariation function by solving an equation system. The regression model is determined by Yule-Walker models. The ARMA model is specific because it has a non-physical nature and it uses autocovariation functions instead of 2D frequencies. The use of 3D covariation, autocovariation functions provides for a number of advantages because the function contains 2 spatial and 1 temporal coordinate. So it enables us to model not only wave propagation but also the wave shape. The model enables us to simulate plane waves, Stokes waves, and plane standing waves. The model is also non-physical, which means that its formulae cannot be produced from equations of mathematical physics. So the model is unable to generate individual waves. It simulates the entire surface, and the distribution of wave parameters on the surface corresponds to the real situation. So in front of you are the so-called diagrams that take several parameters into consideration, such as elevation, height, length, and period. So propagating plane waves have a very high degree of validation. The sample size, small sample sizes can also be used with this formula. The surface can be used to calculate pressures under the surface, below the surface. However, the existing formulae from the linear wave theory are not applicable to such calculations because they only strictly apply to waves with a small amplitude. In reality, we're dealing with small and large waves. The equations fed into the model are the continuity equation, the dynamic BC, and cinematic BC. So our goal is to identify the velocity potential. In the linear theory, the multiplier singled out in red are not considered. So in our work, they are taken into consideration in the equation, which makes our work innovative. The solution was compared with the known solutions. On the left, on top of the graph, you could see the comparison with the linear wave theory for high amplitudes, the synthetic sinusoids. And this is the area where the most of the wave energy is concentrated towards the crest. On the right, on top of the graph, you see the comparison with formulae for wave amplitudes. For small amplitude waves, the solution corresponds to the ones available before. For large amplitude waves, the new solution provides for the correct velocity field. Finally, the comparison with for irregular waves is presented below on the slide. The size of the pressure and velocity field is not changed. The model obtained and our method of pressure calculation were implemented in a suite, in a software suite. The suite also implemented the Longin-Higgins model for comparison. Fourier conversion is used where possible. For the autoregression model, a mini scheduler was created, a mini task planner was created. The autoregression coefficients are calculated using the standard method for symmetrical matrices. The MA coefficients are calculated using the simple iteration method. All the other methods and models are implemented using the Fourier conversion as well as convolutions. Productivity was used both for the OpenAP technology and for OpenCA technology. The autoregression model, as you see from the table, is much more productive, is much more efficient compared with the MA model, despite not using the Fourier conversion. The LH model only applies to Longin-Higgins models. So most of the for the autoregression model, the task planner was used. The planner provides for productivity scaling, which is close to the actual parameters. And it enables the system to perform effectively even if one of the aggregates is dysfunctional. Let us pass on to the conclusions. Our goal was to study alternative models and methods for modeling wave surface outside the linear wave theory. In our work, we have developed a 3D model to generate waves of different amplitudes. We have calculated a method for calculating the pressure field, and the reports on the subjects of the dissertation have been presented at several international conferences. The results of the dissertation have been published in the Ocean in Motion. The regression model was included into the program suite LAMP4 to simulate and to calculate ship pitching. The conference at the HPCS conference received a prize for the best presentation. Thank you for your attention. Thank you. Any questions to ask the defendant? How much time does it take to perform calculations using your software to simulate the waves? That depends on the parameters of the task. What are the parameters and how the time is linked with these? Okay, if you need to generate the implementation, if you need to generate implementation for 1 day with discrete parameters, it will take not more than 5 minutes. This is good. This is good. When you were talking about working with clusters, you used an example for a particular velocity. So, did you study the question of scaling? Where is the bending point and where the larger number of angles will be ineffective? I didn't look into this question because I didn't have access at that time to a large cluster, but I suspect that it will be scaled further because the method is optimized for just boundary points that can be used to calculate the adjacent blocks, adjacent units. So it minimizes the amount of data that is sent via the network. So there are small overhead expenses that that make it possible to do linear scaling. Yes. Any more questions? In modeling wave surface, you use the statistical approaches. Don't you think it would be more correct, it would be more feasible to amalgamate the physical and statistical approaches to for better effect? The point is that the ARMA model has a highly narrow, highly specialized application. So it enables you to see what happens to the ship using the data, using the statistics that can be collected for the ship. So the model works for complexes of this type. I haven't set a goal to provide a model that would absolutely accurately simulate waves. So the simulation is accurate only statistically. What I would add, I would also like to see in your work, and this is something that I didn't see in your work, didn't see in your bibliography. I would have liked to see works on nonlinear waves in the ocean, because our faculty has hosted a number of well-known acclaimed specialists specializing, focusing on ocean waves. Have you looked into these publications? Because it might make a good idea to link this idea with simulation modeling. Yes, I am aware of these works. I have read them. However, this theory is very distant, is very far away from what I'm doing, because the ARMA model cannot generate individual waves. It can generate the surface on the whole, so it will be impossible to analyze individual waves. The waves will be multiple, and all of them will have different parameters. So it is much more feasible to analyze the distribution. If you use nonlinear or complex linear models for the goals that I have specified, namely the generation of different waves, you would need a supercomputer, a very high-power supercomputer. However, with my model, the simulation is very close to the real situation. Yes, I understand the advantages of simulation modeling. This is not half bad. A question that I would like to ask you is this: in your bibliography, I saw just 2 or 3 works, including yours, the work by Professor Degtyarev, and a number of other works on simulation modeling. Are there no other specialists in Russia working in the field? Because I didn't see any Russian authors in your bibliography. My scientific advisor recommended these sources to me. The subject was entirely new because my background is in computer sciences. So I had to start from scratch. I had to start from zero. So the bibliography is not as full as we would have liked to be. Any questions? Any questions from the audience? Yes?
Yes.
Dr. Spiro, any questions?
Yes. Yes, if I may, I'd like to ask one or two questions. Can you hear me?
Несколько вопросов.
Excuse me, can you hear me? Can I ask a question? Hello, can you hear me now? Yes? Can you hear me?
Yes, you can. Yes, you can.
Okay, thank you very much. Mr. Gankevich, I find your work very interesting, but I have one or 2 points that I would like to be clarified. Firstly, could you please explain if there is any upper limit in the stiffness of the waves that can be produced by your ARMA model? In other words, what happens when waves get into the breaking limit? How ARMA model handles this limitation? Is there actually such a limitation in the model, or it just ignores it?
Mr. Spiro, can you repeat your question, because the line is really very bad. I'm sorry.
Okay, I repeat, of course, no problem. Mr. Gankevich, I would like to explain a little bit how your ARMA model handles very steep waves, because the method is supposed to be a generic one. However, I'm wondering what happens.
Sorry. What waves? I cannot hear the type of the waves. Which waves?
Very steep waves. Okay. Can you hear me now?
Yes.
Yes. Now, when waves get close to the limit of breaking, when the waves get close to the limit of breaking, what happens with the ARMA model? How does it handle that case?
Yes. Thank you, Doctor. I heard your question. The steepness of the waves and other parameters are entirely dependent on the choice of the auto-covariation wave. Because if you select the function for a plane wave, you will never end up with a situation when the wave crashes and bends. If you choose a different type of approximation, a different type of auto-covariation function, it's the goal of the researcher to select the function where the bending does not happen. The model itself is unable to handle the situation. You have to select the auto-covariation function correctly in the first place. Any more questions? Are you happy with the response? Are you satisfied?
Yes, that was responsive. May I ask another quick question, actually?
Yes, sure.
Yeah. Mr. Gankevich.
Господин Gankevich.
As I was reading your...
Когда я читал вашу работу,
As I was reading your thesis, it was not very clear to me
мне было не очень понятно,
how your ARMA model actually handles space and time. I think
one more
that
time.
Space and time. Okay. Now, in the initial formulation that you present in the thesis, it looks like that your regression model for the AR part of the model actually uses information from space as well as from time. However, I understand that in the implementation, it uses information only from time. Is that right? Or can you please explain, if you separate the space and the time dependence inside the ARMA model, how you have implemented exactly? Because that part was not very clear to me.
Thank you for your question.
Yeah.
There are two methods, even three, to generate waves. The first option is to generate standing waves using the autoregression model. In this case, you use all the three coordinates, two spatial and one temporal. The other method is to use propagating waves using the MA models, which enables you to use all the three coordinates. And the third option is to use a mixed model, where the autoregression coefficients are used, as well as the MA coefficient. Here you also use all the three coordinates, but the validation sometimes is poor. And this is one of the statements that I make in my work. I haven't been able to study this question in more depth because for these models there are no ways, no methods to match the coefficients. You have to guess every time. So are you satisfied with this answer?
Yes, I understand what you said, and that's fine.
Any more questions? Any more questions from the audience? No more questions. Thank you very much. You can be seated. And let me now give the floor to the members of the Dissertation Council. Margarita, you now have the floor. So I would like to focus on the key aspects of the dissertation. The scientific relevance is beyond doubt because the work aims to expand the existing methods for simulating sea waves. So the methods can be used for controlling different marine objects. The theoretical relevance of the work consists in the fact that the author suggests statistical approaches for simulating modeling. The author has developed a method to compute the pressure field under the wavy surface. The method's selection is entirely justified. The practical relevance of the work is also indubitable, as the author has developed a software suite which can be implemented on the basis of multiprocessor systems. The dissertation provides a detailed description of this software complex. There are many examples that shows high efficiency of the method of this technique. Despite this, there are some drawbacks, some flaws in your work. Number one, the dissertation mentions several sources, published sources, but there is no single section dedicated to publication review. Also, there are different models suggested for. However, the defendant does not discuss the question as to how accurately different ranges of waving can be represented using the AR and the MA models. Question 3. The work suggests selecting coefficients, MA and AR coefficients manually. So some optimization is definitely needed. Finally, the work considers AR and MA models. However, it would be more accurate to use the mixed AR-ARMA model to increase the adequacy of the simulation to the real processes. I would like to conclude by saying that despite the problematic issues. The work does make a really good impression. The dissertation is consistent with the key requirements established by decree on the award of academic degrees at St. Petersburg State University. So Mr. Gankevich merits the academic degree of the candidate of sciences in mathematics, mathematical modeling, and software suites. Thank you. Ivan, would you like to, Ivan Gennadevich, would you like to address the review, the questions right now? Yes. The first remark concerned the review, the literature review. 3 key chapters of the dissertation contain are based on different types of publications, and the articles that I refer to are only loosely linked with each other. So I provided for separate literature reviews for different chapters of the work, for different sections of the work. The second question concerned the work of autoregressive or the autoregressive models and the moving average models. And as I said, the AR and MA models are based on the auto-covariance functions. They can be obtained using the Fourier conversion. The autocovariation function is input, so the function can be measured at the output. And as the Wiener-Hincher theorem calls for the isomorphic ratio between these two, correlation between these two functions, this method is entirely justified. So question number 3 refers to the automated procedure for model selection. Yes, there is an algorithm, optimization algorithm of an iterative nature for optimizing model selection. It has been fully described in works by other researchers. And the algorithm uses symmetrical structures of a autocovariation matrix to iteratively calculate the coefficients for increasing orders of the matrix. The the algorithm works, but it wasn't included in the dissertation. Your last question concerned the use of the mixed model. I have partly addressed this in my previous responses. The use of this model must result in a higher compatibility of the real and generated waves. However, to calculate coefficients, you need to use a procedure that is only known for 1D models. For 3D models, no such formula has been published. So this formula wasn't implemented. It can be used as part of the mixed model. However, it will not coincide with the, it will not correlate with the input function at the output. Are you satisfied with the response? Yes. Okay.
And now the floor is given to Elena Dmitrievna, please. I would like to dwell on some key issues. The work of Ivan Gennadevich aims at the statistic modeling of waves and developing of programming complex that realized implement the model and the method, and I would like to stress that this comprehensiveness is very important for this field, for this, and the new model is a contribution, and especially its connection with the programming complex that is working to implement this model. The work is interesting and very relevant, and as a way of comment, the work says that the model is not based on the linear model, but the function was derived only for sinusoids. But what about the Stokes wave? Is it possible to use this model? As a conclusion, the work of the imitation modeling, simulation modeling of irregular waves for marine object dynamics programs merits the award of the degree of candidate of mathematical and physical sciences, and Mr. Ivan Gankevich can be granted this degree in the aspired field. Thank you very much. The first one is if it's possible to use Stokes waves for generation of waves with this model. Yes, it is. Yeah, it is possible. I actually included it in the presentation. As far as the limitations on the wave profiles, we can use any waves that you can use velocity for coefficients for the waved surface without pressure is not really useful for practical reasons. So this dissertation, Ivan Gankevich worked on the development of a programming complex for generated waves. And this it has a practical application, significance, statistical models for simulation waves is used for velocity to calculate generated velocity waves, wave velocity. The use of statistical model is verified, and it's very important that the input of this program is public, and you can try using this method and verify the applicability of the method. For us, it's very important to see that this work, that new methods have been discussed for multiprocessing and for distributed memory and for clusters and the graphic processors. This topic is very relevant for these type of problems, because they require designers that can effectively guarantee the security of the work, guarantee the work of different units in the ship, and so therefore these methods and the ideas that for designers, ship designers, are very interesting indeed, and the designers. The designer usually traditionally used control points, but in this case you can do away with the control points because it's very time consuming otherwise, and therefore also we also can avoid all other drawbacks of traditional technology, and therefore we have a lot of time. I have a lot of time for this kind of new modeling techniques that are described in the paper. In terms of the comments, the first one is the claims that are formulated in the introduction are not actually mentioned anywhere in the text, and they don't correspond to the conclusions that are provided by the defendant, because and there's a discrepancy between the hypothesis and the conclusions. But other than this, so that the results are not formulated in the introduction. The system of guarantee of parallel applications are not described in better detail. It's the start of the work, and you have continue. We have to compare this method with the other designing methods, and so that a good analysis could be provided. In conclusion, I would like to say that my recommendations are for your future work. The dissertation fully complies with the requirements of St. Petersburg State University on the granting of degrees of candidate of sciences, and Ivan Gennadevich Gankevich merits the award of the sword degree in mathematical and physical sciences. Ivan Gennadevich, please, your answers. Thank you very much. The first comment was about that the claims don't correspond to the conclusions. Well, there's no complete matching. That's true. Well, the conclusions are more about the practical significance of the results. The second one was about that the methods and the algorithms of planning are not they're not deep enough. They're not deeply enough analyzed. But the programming complex is one on the 3 chapters of the dissertation, but it's the largest chapter, and to expand it would be not feasible. A lot of my dissertation deals with other things, and the complex was used only to generate waves. Therefore dedicated analysis was not carried out with this, involving this designer. Thank you very much. I'm satisfied, but the second comment was more not as a way of criticism, but as a way of advice, piece of advice of way to develop your work. This is a very important task, to develop a good planner or good designer that would carry out a lot of tasks. The next review is from my colleague Spiro Konstantinos.
Yes. I found this to be a worthwhile effort for modeling ocean waves, in a way overcoming the well-known shortcomings of the traditional linear superposition of regular waves that is commonly applied in the marine field. I found the work actually very promising, and although I wouldn't consider this thesis to be the definitive answer to the problem, because this is actually a long way to go, nevertheless, it starts discussion in a direction of modeling which had not been used in the marine field when modeling ship dynamics. Now, in ship dynamics nowadays, a key topic is how to handle extreme phenomena, ship behavior in extreme environments. And extreme environments means having to deal with irregular waves, basically. This approach could actually go into that direction and help us determine how a ship behaves in steep wave environment without having to go through the traditional Longier-Higgins approach, which is actually very cumbersome, and we know that it fails when it comes to higher waves. So from this point of view, this work actually is in the right direction, and from my knowledge of the field, I am happy to say that I've seen a few other researchers internationally trying to follow this route after this work first appeared in conferences and workshops. So in fact, I can say that it initiates research in this direction, which is very positive. Of course, there are some weaknesses and have been already pointed out about the way that the ARMA model actually works for real waves. These are directions of future research. I don't think that I need to go back to this discussion. One point of concern is about validation of what is produced by the ARMA model. I understand that direct validation through comparison with, for example, with other analytical methods is not straightforward. Then the question arises how actually you can convince us that what you produce could be a real ocean wave. I mean,
Sorry, Mr. Spiro, can you repeat that last statement again? Sorry.
Yes.
Thank you.
So I think the question of validation is here quite interesting and also important. And a key question here is how Mr. Gankevich could convince us that what he produces through the ARMA model could actually be real ocean waves. I'm happy to see that he did a comparison for the dispersion relationship, and actually he found good coincidence on that. That's good. Perhaps more validation effort could have appeared somehow in the thesis. I think the validation aspect is very important before we use this method in a wider perspective. Also, very important is the calculation of pressures and the wave velocities around the ship or a structure. I would like to raise the issue to Mr. Gankevich why he doesn't actually calculate the forces on a body. I mean, knowing the pressures means that you can actually calculate the forces and then perhaps compare against the traditional Flutsky-Loff calculation of force or anything like that. So in fact, one general comment that I have is that the thesis, as I said, is a very worthwhile thesis. I have a very good opinion about the work. At the same time, I would like to have seen more pictures in the thesis. I mean, the number of figures is, I think, 19 figures. And for a novel work like this, I would think that more applications, more word examples would have been actually good to see in the thesis so that we are convinced that the method works. Now, one more comment is about the title, the English title of the thesis. I have proposed actually in my review, if possible, to modify the title. And my proposal on that was mathematical modeling, the title could be simulation, novel modeling of irregular waves for simulated marine object dynamics. I think this reads better as an English title, although it may not be an exact translation from the Russian title. But the way I read the English title doesn't mean much in the English language. That's my feeling. Okay, so perhaps the title of the thesis in the English language could be adapted somehow. Now, to close this review, I believe that the candidate is worthy the word of the doctor's degree. The thesis represents a worthwhile effort, is quite well written and original, and therefore I have no hesitation in recommending the word of the thesis or the word of the doctor's degree to Mr. Gankevich.
Thank you. You now have the floor to respond to the comments.
Thank you very much for your comments. The first one, how you can improve the verification and validation of the model, ARMA model. And I know it's not a physical model. For us, only statistical methods can be used for verification and validation. And one of the methods is the juxtaposition of distributions. And the other ways of verification can be found in Dekterov, Reed, and Bokanovsky's works, and they prove that there's a dispersal ratio and other characteristics. If we want to use even a better verification, we need a new technique that not only measure the energy specters but also measure time component, so that we could receive autocovariance directly from the sensors and compare it with the results. As far as the calculations of pressure, the work has only one or two of pictures that compare it to the linear theory and other methods. I wanted to use many other comparisons with the known equations, but for calculation of the forces that impact the ship, I haven't done that because it was beyond the scope of my work. the pressure, if you know pressure, that you can calculate the force that impact the ship, and you don't have to devise anything else. Well, this validation has not been carried out because otherwise I would have to find other models to compare it with and to see how they're different from the model that we use. And this is a very interesting direction of work and a very good avenue for my future research. As far as the comments on the title of the dissertation, fortunately I cannot change the text, but I would like to say that I will incorporate your suggestions into the text. Thank you very much for all your comments. They were very, very useful. Are you satisfied with the replies?
Yes, of course.
Thank you very much then. I'd like to read I'm not going to read it out because a lot of things have been already said. Very interesting problem tackled. This is a new research area is being pursued in our faculty relating to the waves. Very interesting direction of work, and it attracts a lot of researchers. The work dwells on a lot of issues, the verification of the model, and a lot of these things were done very well, but the main advantage is the programming software, the software that is of much use. So it can be used not only to carry out this kind of work, but also applicable for other tasks. And this is very good. So, and then my comments in terms of critiques. In formulas 18 and 24, they're not complete. The parts are complete. In formulas, the denominators and right-hand side of the question is actually lost. The error was noticed that the job was done. And so the denominator, these formulas needed. As far as the velocity formula for ocean waves, the denominator in this formula is needed containing squares of spatial derivatives that are small for ocean waves, since their length is several times greater than their height. And so that's the conclusion. Ivan Gankevich's dissertation on simulation of waves and the dynamics of sea objects fully complies with the requirements of the St. Petersburg State University, and the defender merits the right to be awarded the third degree of Candidate of Sciences in mathematical and physical sciences and mathematical modeling and software complexes. Thank you very much. You're now the right to answer. Thank you very much for your comments. First one was that in the formula the denominator was lost. This is true. This error was noticed after the dissertation was actually had gone to the printers, and I used some of the slides that addressed those issues. Second one was about of whether it's feasible to use the multipliers and that the linear theory discards. I'd like to I wanted to, you see, I generated at the bottom of the slide, you see I generated waves with the ARMA model and compared with the real model. Well, there's a very little difference in the pressure field, and it's near the crest, 20% higher. And you see the black dots that show those areas. And the next question related, is also addressed by this picture. The difference is there, but it's not very, it's negligible. Anyone would like to ask a question or make a comment? No, I can't see anyone. All right, then so it's not clear to me if we talk because is it possible to speak before? Because according to the procedure, can we talk after the supervisor speaks? Yes. So the floor is yours, academic supervisor, please. Thank you very much, colleagues. My presentation should be short. I'll be very brief. First of all, I would like to answer very briefly. This work has been done, and maybe the citations were were not there, but he certainly studied Bukhanovsky's work. It was first dissertation that addressed this issue, and had a very good review. Since Bukhanovsky's defense, nothing much has happened in this field. And all the research is within these walls from the Faculty of Geography, from the Department of Oceanology, and I will not speak much about the importance of this work. I will just say that I met Ivan Gennadevich when he was a second-year student, and since then he has defended qualification period, the bachelor's degree, master's degree thesis, and today this is the first PhD candidate that has graduated from computational technologies master's program. And for all this time, as an undergraduate student, and teaching assistant at the department, has always been very responsible, detail conscious, and he was a key worker in a lot of projects, and this work is a part and parcel of those grants and programs, including defense contracts with the state in terms of mathematical the modeling of sea objects in real conditions. And this Ivan teaches, delivers lectures, a lot of he has generated a lot of disciples. He has been the captain and coach of a team of students that won a contest, and then from Russia, represented Russia in supercomputing Olympic Games and abroad, and this is a very star figure really among our students, and he really merits the degree of candidate of sciences in our university. Any questions? I would like to clarify. Bukharsky, is that Bukhanovsky in 1997. So 20 years have passed since his work. Well, not very much, really. Well, in fact, all these works were actually published in the 80s. So, any comments? Yes, please. Yes, please register in the journal. Thank you very much. Please introduce yourself. The microphone's not on. Yesterday, sorry, I forgot to switch it. I'm sort of a supervisor because I'm head of department where Ivan joined, and he came from another institution, but very adaptable and really he is a very responsible, very meticulous, a lot of commendations from me. So, and I will, I can say that I wish we had a lot of people like this, young scientists, because he teaches a lot, has a lot of students, and I cannot vote, but I really endorse this candidate as a well-established academic with a research focus. Of course, there's the things to improve, but that's life. Thank you very much. Any other comments? The procedure stipulates that we have to take a break to discuss the verdict, but before that, I would like to say one more thing. Just a few words. I would like to say that this dissertation is in the computational methods and software development, etc., and physical methods, and so this dissertation completely fits this field, and nothing else to be added, really. And now I would like to have the broadcast switched off, and please, everybody present except the members of the Dissertation Council, may I ask you to leave the room please switch on the broadcast, live broadcast. We finished discussing the issue, and we discussed it very actively. Well, we probably, you know, we even were anxious whether you had left or not. And I would like to now open our Sotnikova Margarita Viktorovna. How do you vote? For? Yes, please raise your hand. Yes. Kotina Yelena Viktorovna Dmitrievna. No, sorry. Yes, for the decision. Vladimir Vasilievich, for the decision. Spiro Konstantinos, would you raise your hand, please?
Yes.
Very good. And Ovsyannikov Dmitry Alexandrovich also vote for the decision to award the degree. And we have the counting of vote is 4-5, no abstentions, no one votes against. So the decision to award the sought degree in physics and mathematics, mathematical modeling, computational methods, and software development. The decision is positive and is taken. So the concluding word from the defendant. I would like to express my gratitude to the Dissertation Council for spending the time, and individually I would like to thank Konstantin Spiro, who was very meticulous and in reading my dissertation, a lot of comments, a lot of criticism, and I would like to implement them all. And thank you very much for everyone for attending, and also those who watch this dissertation defense online, and everybody without whom this dissertation defense would not have happened. Thank you very much. I think we congratulated Ivan Gennadevich with this brilliant defense. Thank you very much, members of the Dissertation Council, for the work, everyone present. And so I close this session. The broadcast should be switched off now. Thank you.